On a freezing January morning in 1986, millions of people watched a spacecraft climb into a clear blue sky. 73 seconds later, it was gone, torn apart in front of the entire world. 7 people died that morning. And the thing that killed them was not a meteor, not sabotage, not some impossible accident no one could have foreseen. It was a small ring of rubber. A simple, cheap seal, the kind of part you would never look at twice. This is the story of how one tiny piece of hardware destroyed the Space Shuttle Challenger, and the far more disturbing truth underneath it, that the people who built it knew it might happen and launched anyway. To understand the disaster, you have to understand what the Space Shuttle was supposed to be. It was the pride of American spaceflight, a reusable spaceship that would fly to space and back again and again like an airliner. By early 1986, the program had become almost routine. Launches barely made the news anymore. NASA wanted to change that, to remind the public why space mattered. So, for this mission, they did something they had never done before. They put an ordinary civilian on board. Her name was Krista McAuliffe, a high school teacher chosen from thousands of applicants to become the first teacher in space. She was going to teach lessons from orbit, beamed directly into classrooms. Because of her, this particular launch was being watched by millions of schoolchildren across the country. Many of them gathered around televisions in their classrooms, waiting to see their teacher fly into the sky. That detail matters because it means the audience for this tragedy included a generation of children. The crew of 7 boarded Challenger that morning as the nation watched. They were experienced, excited, and completely unaware that a decision made the night before had already placed their lives in terrible danger. To send the shuttle into space, 2 enormous solid rocket boosters strapped to its sides provided most of the power at liftoff. These boosters were so large they had to be built in segments and stacked together like sections of a giant tube. And wherever 2 segments met, there was a joint. To stop the searing hot gases inside from escaping through those joints, engineers relied on a deceptively simple solution: rubber seals called O-rings. Thin rings of synthetic rubber seated in the joint, meant to flex and expand in a fraction of a second, to plug any gap and hold back the fire inside the rocket. When everything worked, the O-rings were invisible heroes, holding back an inferno you never thought about. But they had a weakness, and it was a weakness the engineers already knew about. To do their job, the O-rings had to be flexible. They had to be able to squeeze and spring back instantly. And rubber has a problem that anyone who has left a rubber band in the freezer understands. When it gets cold, it goes stiff. It loses its spring. And a seal that cannot spring back fast enough is a seal that can let the fire through. And the morning of this launch was cold. Bitterly, unusually cold. Temperatures around the launch pad had dropped below freezing overnight. There was ice on the structure, icicles hanging from the framework around the spacecraft. It was far colder than any temperature at which the shuttle had ever been launched before. The machine was sitting out in conditions its most critical seals had never been tested in and were never designed for. Think about how ordinary that danger sounds. Not a flaw in some exotic, cutting-edge component, but the simple, everyday fact that rubber gets stiff in the cold. The same thing that happens to a garden hose left out in winter, or a rubber band pulled from a freezer drawer. The most advanced flying machine ever built, carrying 7 human beings toward space, was about to be undone by a problem you could demonstrate in your own kitchen. And the people responsible for it understood that completely. Here is the part that turns a tragedy into something much darker. The engineers knew. The night before the launch, the engineers at the company that built the boosters held an emergency conference call. They were deeply alarmed by the forecast. They knew the cold would stiffen the O-rings. They knew that on previous flights, even in milder cold, the seals had shown dangerous signs of damage, of hot gas beginning to leak past them. One engineer in particular argued, passionately and repeatedly, that launching in this cold was gambling with the crew's lives. He and his colleagues formally recommended that the launch be delayed until it warmed up. But they were under enormous pressure. The launch had already been delayed several times. The schedule was tight, the public was watching, and there was impatience to get Challenger flying. In the meeting, the engineer's warning was challenged and pushed back against. By the end of that long, tense phone call, the recommendation had been reversed. The objections were overruled. The decision was made to launch. The men who understood the danger best had raised their hands and said stop, and they had been told to sit back down. One of those engineers would later say that he knew, the moment the decision was made, that he had just watched something terrible become inevitable. He went home that night certain that the shuttle was going to be destroyed and dreading the morning. He was right. The tragedy of it is almost unbearable. The disaster was not discovered after the fact in some wreckage analysis. It was predicted out loud, by name, the evening before, by the people closest to the machine. The next morning, with ice still clinging to the launch structure, Challenger was cleared to fly. At the moment of ignition, the disaster had already begun, though no one watching could see it. As the boosters lit, the cold, stiffened O-ring in one of the joints failed to seal properly. In the very first second, puffs of black smoke escaped from that joint, a silent signal that fire was already finding its way through a gap that should never have existed. For a few moments, the spacecraft seemed to get lucky. Debris and byproducts from the burning fuel temporarily plugged the leak, forming a fragile, accidental seal where the rubber had failed. Challenger lifted off and began its climb, looking, to everyone watching, like a perfect launch. The crowd cheered. The families watched with pride. The school children cheered for their teacher. For about a minute, everything appeared completely normal. But that fragile, accidental plug holding back the fire was a temporary mercy, and it was about to be torn away. As Challenger powered upward, it hit a region of strong, high-altitude winds. The buffeting shook the vehicle, and it shattered the brittle temporary seal that had been holding back the leak. Now there was nothing. A jet of superheated flame burst out of the side of the booster like a blowtorch, invisible against the bright exhaust. And it was pointed directly at the giant external fuel tank and the strut holding the booster to the spacecraft. The flame burned through metal in seconds. It cut into the massive external tank filled with liquid fuel. And then, 73 seconds into the flight, miles above the Earth and in full view of the world, the tank ruptured and the spacecraft was torn apart in a violent cloud of fire and vapor. To the people on the ground, it was sudden and incomprehensible. One moment, there was a rising spaceship. The next, there were only twisting trails of smoke curling away in the sky and pieces falling toward the ocean far below. For a few terrible seconds, no one fully understood what they were seeing. Mission control fell into a stunned silence, the controllers staring at screens that had gone blank. In the crowd, faces that had been smiling with pride froze in confusion and then collapsed into horror. The cameras tragically kept rolling, capturing the reactions of the families looking up at the sky where the spacecraft had just been. And in classrooms across the country, children who had been cheering for their teacher watched the smoke spread and slowly began to realize that something had gone horribly wrong. All 7 crew members were lost. A teacher and 6 astronauts gone in an instant on a clear winter morning because a rubber seal could not do its job in the cold. In the aftermath, a commission was formed to find out what had happened, and the truth came out with brutal clarity. The investigation zeroed in on the O-rings almost immediately. In one of the most famous moments in the history of engineering, A physicist on the commission performed a stunningly simple demonstration. He took a piece of the same O-ring material, squeezed it in a clamp, and dropped it into a glass of ice water. After a few minutes, he showed that the cold rubber had lost its resilience, that it no longer sprang back into shape. In front of the cameras with a cheap glass of ice water, he had just shown the entire world exactly how 7 people had died. It was a demonstration so simple that a child could understand it, and that was the point. The cause of this enormous tragedy was not some mystery beyond human understanding. It was small and cheap and completely knowable. The disaster was not, in the end, a story about the limits of technology. It was a story about a known flaw and a warning ignored. The weakness of the seals in the cold was not a secret. It had been discussed, documented, and argued about the night before by the very people who built the rockets. The information needed to stop the launch was sitting in the room. The warning was given. It simply was not heeded. And maybe that is the part worth sitting with, and it is the heart of every story on this channel. We like to think of great disasters as bolts from the blue, terrible accidents that no one could have seen coming. But so often, that is not what they are. So often, somebody did see it coming. Somebody did the math, understood the risk, and tried to raise the alarm, only to be overruled by pressure, by schedules, by the desire to believe that it would probably be fine. The Challenger was destroyed by a small ring of rubber, but it was doomed, the night before it ever left the ground, by a choice. So the next time you hear that nobody could have known, ask yourself whether that is really true. Because history is full of disasters that had a moment, just one, where someone could have said stop. If this is the kind of story that stays with you, the next one is already waiting on your screen. Don't look away.